Hello, this is Miss Moore, and today during chemistry we're going to talk about bonds, IMFs, and physical properties. And remember, IMFs means intermolecular forces. Today's essential question: what are the effects of intermolecular forces on physical properties? And we're going to start with a really quick review of types of bonds because they're really important. To determine the types of intermolecular forces you have to know the types of bonds. So we're going to go over these just one more time. So the first type of bond we'll talk about is the ionic bond. So compounds made from atoms that are ionically bonded will always have a metal and a non-metal atom. And then as further review, remember that metals are the atoms to the left of the dark line on the periodic table, jaggedy line, and the nonmetals are to that right of that same line. All right, next type of bond is a metallic bond. So metallic molecules are made from metal atoms only. And you could have one type of metal atom, or a bunch. All right, and then the most complicated of the bonds is the covalent. So molecules made from covalent bonds are non-metal atoms only, one or more. What makes them a little bit more complicated is that there are two types of covalent bonds. You have nonpolar, and recall that nonpolar covalent molecules are also made from only non-metal atoms, but if you look at the periodic table, they'll be touching each other, okay? And polar covalent bonds are also non-metal atoms, but this time they will not be touching each other on the periodic table. All right, so that was just a really quick, fast overview of the three types of bonds. So now on to intermolecular forces and properties of solids. And as a review, remember that substances with the stronger IMFs are going to be polar molecules will always have stronger IMFs than nonpolar molecules, and larger molecules will always have stronger IMFs than nonpolar molecules. No, than smaller molecules, sorry. Okay, so substances with stronger IMFs will have high melting points, which means it needs a melting point as the temperature at which a substance will melt. Melting point. And a high melting point means a high temperature. A boiling point, same idea, except for well, let's go back. A melting point would be going from a solid to a liquid, right? Boiling point is going from a liquid to a gas. It's the temperature at which a substance will start boiling. Substances with stronger IMFs will have a high density, and density equals mass over volume. So you think about, for density, the way I like to think about it, it's how much stuff is packed into one small space. Something small and heavy would be more dense than something small and light. Like, so for example, or big and light, doesn't really matter. But if I had like a big giant boulder, right? It's like a huge boulder, and I try to pick it up, way too heavy. But then I'm on a movie set and I have a styrofoam boulder, same size, I can pick it up. They're the same size, same volume, but the real boulder has more particles, whereas the styrofoam has a lot of space in it, has less mass, less particles, so it's less dense. Okay, substances with stronger IMFs also have a high viscosity. Viscosity is, ability to flow. So something with high viscosity would be like honey. Honey has a high viscosity. Something with a lower viscosity would be like water. water has a much lower viscosity than honey, it flows easier. Substances with stronger IMFs also have a low evaporation rate. And evaporation is really going from water on the ground in the morning, and then the sun comes up, right, and the water evaporates. Evaporation is really, if you think about it, it's boiling, right? It's a way to think about it. It's going from a liquid to a gas. Okay, and the reason it has a low evaporation rate is because it has a high boiling point. So again, substances with stronger IMFs, these polar and larger molecules, will have high melting points, high boiling points, high density, high viscosity, and low evaporation rates. So let's now compare that to substances with weaker IMFs. And just as a preview, it's going to be the opposite. Okay, so substances with weaker IMFs are going to be nonpolar and weaker, how about that? And smaller molecules. All right, so substances with weaker IMFs are going to have lower melting points, lower boiling points, lower density. So think styrofoam versus the rock. We're talking about density. Low viscosity, meaning it flows easier, and a higher evaporation rate because it has a lower boiling point. One more note here, water. Water is really, really, really special in that it has a much higher melting and boiling point than would be predicted. That's because it contains a very, very special type of IMF. There are a few other molecules that contain this particular IMF, but we're going to stick with just water, and that's the hydrogen bond. And the hydrogen bond is the strongest of all IMFs. But for us, it'll just be water that has the hydrogen bond. All right, I'd like to finish up today doing kind of a review slide that puts everything together that we've learned, and hopefully it'll be helpful for your worksheets and the tests and everything. So I'm going to call this my strength line. And we're going to rank everything from the left side being the strongest to the right side being the weakest. Okay, so going from left to right, strongest to weakest. So between IMFs and bonds, which is stronger? Well, definitely the bonds. So the bonds are going to be way over on the left, and the IMFs are going to be on the right. So let's rank our bonds. Our first type of bond, the strongest bond, is ionic. Right? And then our next weakest bond is our metallic. And then our weakest of all three is covalent. And then we go to IMFs. And for us, when we're talking about IMFs, it's the covalent bonds that are going to be participating in the IMFs. All right, so the strongest of the IMFs is the hydrogen bond. And for us, that's only going to pertain to water, okay? It's the special one. And then our next one would be polar. Large polar molecules, and then small polar molecules, and then large non-polar, and then last is small non-polar. Okay, so from this strength line, what you should be able to see is that bonds are stronger than IMFs, And if we were to rank things, you would start with ionic, metallic, and covalent for strength of bonds. And then within the covalent, if you have water, it will be the strongest of the covalent because of the IMFs, and then large polar molecules, small polar molecules, large nonpolar, and small nonpolar. Let's fit in our characteristics as well in our number line. So on the left, what are the characteristics of something that's strong, whether we're talking stronger IMF, stronger bonds, either way. So the stronger are going to have high melting temperatures, high boiling temperatures, high density, high viscosity, and low evaporation temperatures. No, low evaporation rate because it has a high boiling point. Okay, and then as you move to go to the weaker side, you're going to end up with lower melting temperatures, low boiling temperatures, low density, low viscosity, and a high evaporation rate. So on this screen, if I zoom a little bit, this right here, really, this is the entire unit. If you can really learn this, write it out so you can read it, you're going to do well. And remember, for every single problem you do, whether it's on a worksheet, on the test, whatever, what you have to do is figure out the type of bond. That's the very first thing you have to do. Okay? And then next is figure out the type of IMF. And then from there, you'll be able to tell which has got a higher or lower melting point or boiling point. All right, folks, that's it for today. Have a good one.